Nope. Don't remember that. Okay. I want to look at example 2. They're starting out with giving you the x value of some unknown angle at 0.34. I don't know what this is. This is from section 5.1. I don't know what the angle is, and I don't care. I know. It's heartless, ruthless, but I really don't. I mean, if you really want me to think through this whole process, I know the x value 1/2 is right there, so I can estimate that 0.34 is right here. So I either know the angle is something like that, maybe 75 to 80 degrees, or it's down here. I assume we're starting with a first quadrant angle. So they're asking me about theta minus pi over 2. Now that's kind of weird, because usually we talk about pi over 2 minus theta. We have an identity, right? We have an identity that says something like this: the sine of negative theta is equal to the negative sine of theta. Now, what did we decide? What do we know about sine? Is it odd or even? Should be in your notes. It's an odd function, right? Since it's an odd function, opposite x's produce opposite y's, and what you need to really understand about that is when we pull the negative out, it stays out. It doesn't disappear. So I want you to see something that they did here. Since they asked about theta minus pi over 2, which is kind of weird. Usually we ask about pi over 2 minus theta. What was the first thing they did? They rewrote this as the sine of negative 1 times pi over 2 minus theta. They pulled a negative out of it. And then what's going to happen to this negative 1? It goes out in front because of the fact that the sine is an odd function. It doesn't disappear like with an even function. This is why you see this negative right here, because they pulled it out. So they kind of did 2 steps at once, and so that's why I wanted to expand on that. Yes, Ms. Johnson. Theta, okay, so if you look right here, you see how theta is positive? But when you pull out a negative 1, then that would make it negative. Yes. Then what you should do is you should try to close it out. First I'd try to save it. Then I would close it and then reopen it with edge again. And I've seen that happen where it won't erase, and then when you close it and reopen it, it will let you continue working on the document the right way. Okay, do we at least have that understanding so far? They pulled out a negative 1, and then that negative 1 could come out in front. Then they decided to replace what's in this blue box. What can we replace that with? That's cosine. From your identities that we looked at, up above, we talked about how, and the one in the red right there, we could substitute cosine theta in there. So that's what they did. They said that the negative 1 stayed out in front, and they replaced what's in the blue box with cosine theta. Well, guess what? We already know cosine theta. So they just plugged in the number to give you the final answer, negative 0.34. Yes, cheesy and lemon squeezy. Any questions about this? All right, next. Example 3. Simplifying by factoring and using identities. Okay, so if we want to simplify this expression, I think you should look. There are a few things that we really need to pay attention to. Okay, when you're trying to simplify these things, do we have any kind of denominators that we have to make common denominators? Is that true for this problem? No. No denominators that we have to worry about. I see a greatest common factor that we can pull out. Do you see the greatest common factor? They both have what? Sine x. Okay? You've got sine cubed x plus sine x cosine squared x. Do you see that both of them have a sine x? We pull it out. What do we have left? All right, now I'm going to walk away while you finish. I want you to write here. 1. Okay, so this was sine x times 1, which is plain old sine x. Okay? The Pythagorean identity led you to do the substitution and get 1. I hope that you saw that and were able to do that, since that wasn't too bad of a question. Okay? Now, I don't like the way they've written this, so I'm going to write it a different way. So we've got secant x plus 1 times secant x minus 1 all over sine squared x. What can you do with this stuff on top? Foil, thank you very much. Put it together. Just like, what was that? That's from Mary Poppins, right? Put it together, and what do you got? Is that right? No? Yeah. Stop it! Bippity boppity boo? Is it? Oh, okay, yeah. Yeah, I was way off there. Whew, man. All right, so when you FOIL it, what do you get? Secant squared x minus 1, and that's it, because the insides and the outsides cancel each other out because we just multiplied conjugates together. Hopefully what you saw was they were setting you up for a difference of perfect squares. Now, next on your list, what do you have up there that you can substitute? Look back at your trig identities. Don't tell him, don't tell him. Okay, I'm going to pause. What are we substituting for secant squared x minus 1? Tan squared x. Okay, we looked back at our Pythagorean identity somewhere back in my notes. There we go. The one in the red right there. Okay, if you subtract 1 to the other side, secant squared theta minus 1 would be tangent squared. So, that's what we were using. Okay, now, it's possible that it would be better if I wrote this out horizontally now, so that we can see if something cancels. Tan squared, what's another way to say tan squared? Sine squared over cosine squared. And division is the same as multiplying by the reciprocal. Anything canceling out? Right, giving me 1 over cosine squared x, also known on the street as. Lost you at canceling out? This one right here, by definition, tangent is sine over cosine. So because it's squared, it would be sine squared over cosine squared. Now, secant squared, okay? So there's my final answer for that question. All right? Okay, now. Simplifying the expression. This one has to get common denominators. All right? Otherwise, you're not going to be able to add the two fractions together. All right. Now, when you were in elementary school many moons ago, they might ask you to add 1/2 and 1/3. And since 2 and 3 don't share anything in common, what were you forced to do to find a common denominator? You had to multiply them together, right? And so obviously you multiplied this one by 3 to the top and bottom, and this one by 2 to the top and the bottom. Okay, 1 minus sine x and cosine x don't share anything in common. Therefore, you must multiply top and bottom by the other one. When I get this written out, then I'll answer your question. What's your question? Doesn't what cancel each other out? Okay, if you start, okay, number one, okay, maybe we need to walk down memory lane here. So this particular problem up here at the top, wasn't that 3/6 plus 2/6? Okay, can you tell me what you get? Please don't say 5/12. What is it? 5 over what? 6. In other words, the denominator doesn't change, right? It's only the numerators that get added together. Now, I hope that's what you mean, or what you were talking about, because subtraction, we don't do anything with those denominators until we can combine that numerator together. What is cosine x times cosine x? That's cosine squared x, right? Well, if you put parentheses around cosine x and put the square on the outside, it would be the same thing. Okay? We just don't want to get it confused with cosine x squared, because we're not squaring the x, we're squaring the cosine. So that's the difference. So if you use parentheses, then you'd be okay. But so to avoid that, we just put it in front. Okay? Right here I have minus sine x. That minus sine x is going to get distributed, right? What is minus sine x times 1? Minus sine x times 1. Minus sine x. What is minus sine x times minus sine x? Plus sine squared x. Right? Because the two negatives cancel. All over. Now, just hold on to the denominator the way it is. Don't mess with it yet. Okay? What do you see in the numerator that would be really helpful right now? You see it? I'm so happy, folks. Look at the green part. Look at that green part. The part that's in the green that I circled, what is it? 1. It's the Pythagorean identity. It was hiding on the top. Folks, we can rearrange the terms. It's called the commutative property of addition. Okay, so it would be 1 minus sine x on the top. It'd be 1 minus sine x times cosine x on the bottom. What were you saying, Mr. Lazar? Boom, boom. Well, be careful. What's on the top there?
1.
1. You are. Okay. Well, actually, I equals the square root of negative 1, but that's okay. All right, so 1 over cosine x. Give me another name for it. Secant x.
Do you have to do that part? Why?
Yes, you do. Okay. Folks, some people do not realize that when you cancel all the factors, either from the numerator or the denominator, 1 will be there. Okay, you can't forget about 1. Okay? He's a great guy. Don't forget about 1. Okay? I need you to work on the rest of those homework problems. I think we need to, I'll look and I'll change it. I'll change the problems because we didn't get to example 6. Folks, we'll continue working on this tomorrow. Okay, find all the values of x in the interval. Specifically, they've chosen 0 to 2 pi, so that's once around the circle. Okay, normally he comes over here for advisory, so he just shifted his stuff. Never mind. Gone. Okay, my fault. Okay, folks, this is an equation. Okay, now we're entering the world of equations. We've got cosine cubed x over sine x equaling cotangent of x. We are going to more than likely put everything on the same side. Is there anything we could replace cotangent with? What could we replace that with? We could do 1 over tangent, but because the other side has cosines and sines, I think it would be better to change it into something else. Cosine x over sine x. Now, how are we going to get that thing to move to the same side as the other stuff? We're going to subtract it, aren't we? Okay? So, here, I'll try to zoom out for those of you copying things down here. So we're going to have cosine cubed x, and then you can ask your question here in a second, minus cosine x over sine x equals 0. Are you with me so far? Okay. Do you see something common that you can pull out of these? Do you see a common thing that you can pull out? We could pull a cosine out of the top and what out of the bottom? Sine. So I'm actually going to have cosine x over sine x. And then what would I be left with here? Cosine squared x. And what are you left here when you pull the whole thing out? 1, right? So far, are we looking okay? Now, all I'm doing is using my algebra skills. What can we substitute for this? Look back at your Pythagorean identity. Isn't that sine squared? Now, anything cancel out? 1 of the sines, right? Cosine x times sine x equals 0. Now, this is in the factored form just like we did in Algebra 2. When you have two things that are multiplied together to get equal 0, what do you know about one of those things? One of them has to be 0. So we set them both equal to 0 and solve, and we will continue tomorrow.